Hi everyone, my name is Eleni. My surname is Fragkiadaki, so good luck pronouncing that. So let's stick with Eleni, and I'm going to be talking to you today about Go tests and how do we start writing tests in Go, going from nothing. So we create a new project, we start writing our first tests, we talk about table-driven tests, subtests, how we can use table-driven subtests, and how we can run our tests in parallel, and what does that mean. So the first thing is, let's create the first package. So we create a repository, it's called parallel tests. I have all the examples on a repo on GitHub if you want to download it later. And I'm using deb to initialize the project. One interesting thing, if you're using deb to do that, you will see in your Go package toml, you will see that there is a prune section, and in there it says Go test true and unused packages equals true. This actually means that when you look at the vendor packages that you have downloaded, you won't see any tests there because they will be getting removed by deb itself. Okay, so what does our package look like? Our package is very simple. We just initialized it, so it has all the basic files in it, and we have created one package in it, which is called search, and we have implemented a binary search, and we have implemented the iterative version of a binary search, which means that we have a slice of integers. We are looking for a number. If we find the number, we return the position. If we don't find the number, we will be returning -1. We will be using this one throughout the talk just to introduce the tests. How do we write a simple test? Tests in Go actually sit right next to the code. Yes, actually sit right next to the code, and they are in files that are called something_test.go. In there, you create your test functions, and each test function starts with the word test and then something meaningful so that you can identify which test you are running. This is a very simple example where we have created a test. We have the slice. We are checking that we find the number 30 in the slice. And if we haven't found the number 30 at position 2, we know that our code is not working correctly, and we will be raising an error, and therefore our test will fail. If you want to run the test, you would go on the command line, and you would just do go test, providing the path where your package lives, and Go will print out a message saying, yes, I ran your tests, everything is okay, and it took 0.003 seconds to execute them. This is very useful if you're running a huge suite and you want to see if the individual packages succeed. But if you want to get more information, it's very useful to go with go test-v, where -v is a test flag that you can provide that will actually tell you which tests have run, and for each of them, if they have passed or failed, giving you the same OK line at the end saying, yes, this package has successfully been tested. Another example here. We want to test another case where the number is not actually in the list, so we want to search for the number 35. If we're expecting it to not be found, and again, if we get anything other than -1, the test will fail. We do the run test again, and we see now that we have 4 lines, a pair of 2 lines for each of the test cases that we run with 2 successes. Now we want to run another test. So we created another test because we identified that some of the code that we were writing within our test was actually repetitive. So we said, let's not do that. Let's define a simple test that has the list and runs 3 cases in it so that we can have everything condensed in a single case. We run it again with go test-v, and we can see the result on the left. Now this is fine, but we can do better, and we can write a better looking test with more clean code if we start using table-driven tests. Table-driven test is actually a neat way. It's not specific to Go, but we can use it in Go as well, where we define our test cases as a slice with all the parameters that we need to be specifying for our test defined within the structure that we have. So each line here is actually a test case where we are checking for a specific scenario. So the first one is we have a list. We want to find the element at position 2. The second example is a list. We have an element that we don't have in the list, so we wanted to return -1. And the last one is an empty list, where again we want to return -1. The way to use the table-driven test is that we define this slice of test cases, and then we iterate through it. So we use a for loop to iterate through that. And our code now is a lot cleaner and more condensed because we have a standard way of actually looping through all the cases that we want. So this is really cool. And when we run the actual output, we will see again the lines of run test table, and then we pass the test table. Let's move on to subtests. And what is the difference between table tests and subtests? So Go introduced a new feature that allows us to run subtests within a parent test case. So in this case, function test sub basic is going to be testing the same iterative function as before, but this time around, instead of having the code isolated, the code repeated, we use the t.run method. The t.run method accepts a parameter with the first parameter, which is the name, and then it has the function, which is the test to actually be executed. The difference between this one and the thing that we were doing before is not big, right? Because the test that we are executing is exactly the same. We run the iterative function, we check for the resulting element, we raise an error if the test failed. The difference here comes when we actually run the tests. So when you see the results in this case, you will see that we have added the test sub basic. And now we can see not only that the test itself has passed, but we can see for each of the subtests that we run within that parent case that they have run and the name and whether they have passed or not. So Go will transform the first parameter, which is the item found, into underscores, and it will connect all the parts of the string there to give us a meaningful output. This is very nice because that gives us a lot more visibility when we do actually look at the results of the test. What else we can do with the run method? We can also use the command line -run in order to start filtering which tests we want to be running when we execute the test suite that we have. In the top example, we can filter for the ones that start with test simple, and we can see that we only picked up the test that their name starts with test simple. And you can also go even further, and you can actually filter for the tests, the subtests within parent test cases. So in the second example, we can filter by saying test sub basic / item found, and this will only match that subtest and run that for you. What else is interesting with subtests? Subtests actually run in separate goroutines. So when you write the parent case, so when you write func test sub details, we have the top level, the top part of the test, the top 2 lines. Then we have defined the 2 subtests, and then we have some code at the end. What Go does with that is it starts executing from the top of the file, from the top of the test. It will run the first 2 lines, then it will spawn 2 separate goroutines to run the subtest, and then it will come back and do the cleanup. So you can think of the code before the subtest and after the test as setting up the tests and tearing down the tests. And this can be very useful. A way that we can actually see what happens here is by running the tests again, and tlog is a simple testing function that will start printing things on the output. So in this case, we run it, we just filter for this test, and it will print 1 line at the beginning and 1 line at the end. If we run it again, but this time filtering for the subtest, again we will see that Go actually did run the setup code and the teardown code, and the setup and teardown will only be run once, even if you do go and filter for the subtest that you have within your parent test case, which I found really useful in many, many cases. Okay, so let's take it a step further and combine everything so far. We want to be writing table-driven tests with subtests. So we define again our structure, the slice at the beginning, and we start defining all the cases that we want. But this time around, we are also going to define a name for each of the test cases. We do that, and inside the for loop, we replace the code that we had before, and we encapsulate it in the trun method using the tc.name from the struct that we have created. When you run the test now, you will actually be able to see in the output not only that the test ran, but also the names of each of the test cases. And the test looks a lot cleaner and a lot easier to start appending cases in the list that we have, in the slice that we have. Cool. So, test execution in Go. The way we ran the test so far was by triggering it from the command line, and we said go test the path for our test, and we've used 2 flags. So we have used the -v in order to have more verbose output, and we used the -run if we wanted to filter the results. There is one more thing that we can use, which is the dust trace. Dust trace is very, very useful. If you haven't used the trace tool at all, I would definitely recommend having a look. It can give you a lot of information about like the processes that Go has used, the goroutines, how the execution looks like, all sorts of information about like waiting times, syscalls, all of that. And not only that, you can generate the .out file, and once you generate the .out file, you can use it as well on the web. The way to trigger the web tool is by doing the first command, which is go test dash trace, name of trace file, plus the test to run, and then go tool trace with the trace.out file, and it will trigger a browser, and you can click through the trace tool online. So I've taken screenshots for this presentation, but this is what it would look like. Very quickly, at the top, you can see that we have information about the goroutines, we have the heap and the threads, and at the bottom, we have a breakdown of all the goroutines that we are using. This is from the output of the test that we have written so far, and you can see going to the right, we actually have the time, and going down, we have the execution of the different tests that we've written. What this shows us is that everything goes to the main, and then it goes down to one of the tests, and then goes up to the main, down to the test, up to the main, down to the test, and this will continue for all the tests that we have written. It's very interesting to see at the middle of this. So let me just see if I can move my, yeah. So this is very interesting to see. This is the test, and these are subtests that we have defined. So this is what a test with subtests would look like. This is another example, and this is another example. Let's zoom in a little bit to be able to see better when we start talking about parallel tests. I've just run the same thing, but filtering only for the test simple, and we can see the execution of the test again here, but it's like bigger, and we can more easily see what we are doing. Now, if we wanted now to start writing our test in parallel, running the test in parallel, there's only one thing that we need to change in our test. We need to add the t.parallel line, and we go ahead and do that in all the ones that we have been talking about. So we add actually this line, and this line as the first line in our test. And this will instruct Go to actually run the test in parallel. If we generate the trace again, and this is a really nice way to see it, we will see the difference between the previous slide, which is this one, everything runs sequentially, to this one, where now we have the main, scheduling happens, and then the execution actually happens in parallel. And we can actually see that nicely on the graph. Let's go ahead and add the t.parallel everywhere, right? So we have all our tests. Let's go add it everywhere. Now, this looks a little bit more messy, because now things do not like extend to infinity, but they start running in parallel, and we can see a few interesting things if we zoom in a little bit here. So here we can see that the test started running in parallel, but if we look at this case, this doesn't run in parallel. So this is a case where we have subtests, and although the parent case runs in parallel, the subtests actually still run sequentially. How we can fix that? We can fix that by going into the subtest and adding the same line again. So we add the t.parallel line inside the subtest that we have created. And in this case, where the subtest is the simple case, where we just define the subtest one after the other, we just add this line. In this case, where we have the subtable test, we add the line here, but also add the line here. So we added the tc : equals tc there. Let's run it again. Now that we have run it again, we can see again, same kind of like a little bit messy view of how the test executed. But if we zoom in here, we will actually be able to see that the subtests for this test also run in parallel. So now we have run all the tests in parallel and the subtests as well. Cool. Some tips about running tests in parallel. Go has a concept of Go max procs, and that defines a lot of things. So it defines how many cores basically are available for Go to run threads on so that they can schedule things. Another thing that it's used for is to define how many goroutines Go will actually be able to run in parallel for the tests to run in parallel. So in my case, when I run this, I have a computer that has 4 CPUs, and it doesn't have multi-threading, and it has 4 goroutines running in parallel. But we can actually affect that. We can change that behavior, the default behavior that Go has. By providing a parameter which is called -parallel, we can identify how many goroutines we want to use when we are running our test in parallel. So in this example, and just to demonstrate, I've put parallel equals 1, And this shows us that Go goes through all the steps of scheduling, but eventually everything gets executed sequentially, because we said you can only have one running at any given time. Second thing, we could run tests in parallel, but what happens when we have more than one packages? So Go runs things in parallel for packages as well, and there is a different parameter that we can specify when we actually trigger our test from the command line if we want to affect that behavior as well. So does parallel defines how many goroutines from within the same package, so how many things from within the same package will be running in parallel. Does P defines how many packages we will be able to do that for. Adding a second package is just an example here, so how we can actually see that. We created another one which is called sort. It has code in it and it has some test cases, and if we execute it, we will actually see that it comes up as 2 lines now. One line appears as cached, and we'll talk about that in a bit, and then we have the second line, which is the second package. Cool. So yes, so use the -p if you want to actually run them in parallel, and again, Go max procs is what defines how many packages can be run in parallel. Tip number 3. We talked a bit before about adding the tc : tc line when we are doing table-driven subtests. And we're going to talk a little bit about why that is important to do. So in this case, inside our binary package, we're also introducing another function, which is called iterative with error. And that is just for us to be able to trigger an error on the tests, right? So what this does, whenever we call it, if we pass it a slice that has 3 elements, it's going to error. If we pass it anything else, it's passing through to the previous function, to the correct behavior. Again, this is just for us to be able to trigger errors in the test, not something that we want to be doing. And we are going to change the test here a little bit, and we are going to run it twice, one with the tc : tc, and one without, and see what the resulting is. I would say things to pay attention to here. The test that is meant to be failing is the third one, right? So we have the first one, which is found, the second one, which is the empty list, and then we added the third one, which is 3 elements, which we wanted to actually fail. Let's run it once with tc : tc in there. This actually tells us that we filtered it, so we used the test error, count 1, ignore it, I'll tell you about that in a bit, and then we can see that our test case actually failed, which is expected. This is what we wanted. We added it on purpose so that it would fail. Let's now remove the tc : tc and see what happens. If we do that, then we will see that suddenly all 3 test cases failed. And the reason for that is that when the test actually ran, tc had gotten the last element from the list, and it was always getting the last one, which is actually failing. And this is because we didn't do this tc : tc. So we didn't actually bind the variable while we were executing the test. This is interesting because if the failing test case was not the third one on the list, but it was the first one or the second one, our variable would have bound to the last one, which would have been the successful test, and we would not have seen the first one that could have actually been a failed test. Okay, and last one, cacheable tests and cacheable test results. So Go has 2 ways of running tests. One is by files, and the other one is by providing a package name. In all the tests that we run, we provided a package name, or we were in the package listing mode test of Go. When that happens, Go actually looks at what we are running, looks at what parameters have we provided on the command line, and looks about whether the test results were actually successful. If all of these are true, so the binary file has not changed, the flags have not changed, and they are part of a specific set of flags, and the test results were successful, Go will actually cache that result. So it will tell you that cached value that you see at the end. Now, in some cases, that's good because it speeds up things, but in some cases, you might not want to do that. So if you don't want to do that and you want to tell Go, in any case, I don't care what the previous execution was, I want you to rerun my test, then you need to add that dash count equals 1 as a parameter when you're running the test from the command line. Now, count as a parameter on the command line actually just means only run my tests once. The reason why that triggers that behavior is because count is not one of the cacheable parameters that you can use when you're running your tests. And when Go sees that, it will go, okay, so you want me to rerun them, and therefore I'm going to do that. So the bottom bit is how you would actually trigger that behavior. Cool. That was me, going from 0 to 1 in writing tests, and a couple of tips of how you can do that. You can find the code on GitHub, you can find me on Twitter, and that's it. Thank you.